Large language models are highly capable pattern matchers, but struggle in a live, unstructured environment. Without a filter, an autonomous agent drowns in the noise. LLMs often fail at complex, sequential tasks because they cannot reliably parse raw reality. Messy terminal outputs or unsynchronized 360-degree video feeds present a level of entropy that breaks the model's reasoning chain. True agentic autonomy requires a strict translation layer. This layer must intercept the chaotic outputs of the environment and convert them into structured, queryable schemas. Without a deterministic bridge, an agent cannot accurately evaluate its current state. If the model can't see the reality of its execution, it can't self-heal or iterate effectively. This problem is typically solved in software development through a local test harness, a controlled environment designed to safely execute and evaluate code within a sandbox. A reliable harness rests on 4 pillars: isolation, state management, structured telemetry, and an agentic controller. Isolation uses disposable containers, so code cannot pollute the system. Telemetry capture parses raw text into machine-readable formats, allowing the agent to query structured data. These pillars suggest a blueprint for more than just code. The same constraints used to validate a Python script offer a potential path for automating something much more complex: a multi-camera, data-driven video production. By applying micro-scale code sandbox logic to the macro-scale of media production, we can replace manual creative guesswork with deterministic execution. In a local code harness, the agent operates under a strict execution contract. It can only interact with the environment through standardized CLI commands, not through arbitrary shell access. We establish guardrails by setting sub-process timeouts and resource quotas. These restrict the CPU and memory usage of any single execution. These guardrails act as physical boundaries. If the AI generates an infinite loop, the harness forcibly terminates the process before it can affect the host system. The telemetry parser acts as the bridge between this execution and the agent. When a framework like PyTest or RSpec crashes, the parser script intercepts the raw error code. It normalizes the traceback into a strict JSON payload, stripping away the noise to leave only the essential data: the file, the line number, and the specific exception. The agent only sees this final schema. Because it targets a specific, structured failing assertion, it can generate a fix without hallucinating the context of the error. Moving from raw terminal text to normalized key-value pairs is what allows for deterministic self-healing. The model isn't interpreting a story, it's responding to a data point. We can scale this same logic to the physical world using Studio OS, a production engine designed to handle multimodal media. Modern production involves unsynchronized assets: spherical video from an Insta360, aerial drone footage, and GPX telemetry from vehicles moving through the landscape. Here, the code testing architecture is applied to media. The test runner is replaced by automated rendering tools, and the code state is replaced by physical hardware telemetry. The system synchronizes physical hardware states with video timecodes, creating a unified production manifest. Every frame is pinned to specific metrics: velocity, voltage sag, and amperage draw. Python scripts then execute the edit purely based on the peaks in this telemetry data. When the GPX data shows a highlight in the route, or the battery logs indicate a specific draw, the system triggers camera pivots and reframing autonomously. Mapping these decisions to hardware data prevents the AI from hallucinating edits. It can only cut to what the sensors actually recorded. Just as a JSON schema stabilizes code generation, synchronized physical telemetry stabilizes video generation. The AI is forced to edit based on physical reality. Coordinating this pipeline over multiple episodes is the job of the Maestro interface, the central agentic orchestrator. It operates within an anti-gravity workspace, a system designed to manage the long-term state and memory of the orchestrator. To prevent data loss across releases, the orchestrator queries a local SQLite database to retrieve historical logs and route data. This information maintains the agents.md file, a dynamic governance document that sets the behavioral rules for the agent. After each run, the Maestro interface updates this file with positive and negative constraints based on the performance of the pipeline. Negative constraints prohibit artificial marketing hype and the use of generic filler language. Hallucinated hardware stats are strictly blocked. Positive constraints mandate technical candor and ensure the output matches the exact delivery and cadence of the human creator. This creates a meta character. The AI becomes a grounded, collaborative node in the production, working alongside the physical rider and the bike. Continuous state management ensures that even an automated pipeline produces authentic content, avoiding the predictable patterns of generic synthetic media. The Studio OS prompt architecture provides the final layer of enforcement, binding the pipeline to the telemetry rules. Structurally, the prompt limits the AI's reasoning engine. It cannot generate narrative beats that are not explicitly supported by the verified data schemas. A critical part of this design is separating the story from the distribution funnel. The core narrative prompts are isolated from the direct network endpoints used for final delivery. Metadata, like SEO titles, tags, and YouTube chapters, is handled downstream by dedicated pipeline loaders. This keeps the core AI focused entirely on narrative fidelity. By isolating creative logic from distribution mechanics, the architecture remains modular, grounded in data. There is a common idea that autonomous AI requires limitless freedom and completely unconstrained access to its external environment. But unconstrained models inevitably degrade. When forced to execute complex physical tasks, they drift into hallucination. Studio OS takes the opposite approach, relying on hyper-constrained generation, where the AI functions as a translation node for existing data. Real autonomy requires rigid test harnesses, standardized data schemas, and rigorous local loops. To build a reliable system, whether it's fixing a script or editing a video, you don't start with freedom. You start by engineering the box.